Hello, this lecture will discuss about what is microcontroller. We will describe the classification and architecture of a microcontroller. Microcontrollers are programmable devices. They play an important role in the world of embedded systems. Most technological devices around us are built with a microcontroller. Microcontrollers integrate all the components of a computer system onto a single chip. So it's a small computer having processor core, memory elements, and programmable input-output modules. It's a device that captures the input, processes it, and generates output based on the information captured. So it can be used for signal processing. It can be used as a processor. Microcontrollers are classified into various categories based on memory, architecture, bit configuration, and instruction sets. Concerning the memory, we have internal and external memory microcontrollers. External memory microcontrollers do not have a program memory on the chip. However, the embedded memory microcontroller has all programs and data memory, also has counters, timers, interrupts, also input-output ports embedded on the chip. We have two types of microcontroller architectures, the von Neumann and the Harvard architecture. Also, there are three types of microcontrollers based on bit configuration. We have 8-bit microcontroller, 16-bit microcontroller, and 32-bit microcontrollers. 8-bit is basically used to execute arithmetic and logic operations like addition, subtraction, multiplication, division. So it processes 8 bits of data at a time. The 16-bit microcontroller is used in applications where higher accuracy and performance is required. The 32-bit microcontroller offers superior processing speed and can handle multiple peripherals and generally used in automatically controlled appliances, like for example the medical appliances and computer applications. Microcontroller is also classified into two types based on the instruction sets. They are the CISC and RISC type. So we have two architectures, the Harvard architecture and von Neumann architecture. Harvard architecture has separate memory units for program and data storage, and it has separate buses for transfer of data and instructions. So here we have two buses, two separate buses. So in Harvard architecture, the data access and address access are separate. Thus, a greater flow of data is possible through the central processing unit. However, in von Neumann architecture, we have only one bus between the CPU and the memory. Also, the RAM and program memory share the same bus and the same memory. So this type of architecture has common memory for storage of data and programs. Concerning the instruction set categories, so we have two categories, the CISC and RISC. The CISC means complex instruction set computer. It allows the user to apply one instruction as an alternative to many simple instructions. RISC means reduced instruction set computers. It reduces the operation time by shortening the clock cycle per instruction. So the RISC processors have smaller set of instructions, have few instructions with few addressing modes. The CISC processors have large set of instructions with many addressing modes. In CISC mode, the instructions can take several clock cycles. Let's see some applications using microcontrollers. First of all, we have applications in day-to-day life devices. In some devices like in a refrigerator, like in laptops, in the car, in the treadmill. In all these devices, we can find the microcontroller. Microcontrollers have applications in home automation, so we can make our home automatic. We can control sensors, we can control cameras, we can control all the electrical appliances inside our home. It has also applications in metering and measurement devices. It can be used as a voltmeter, as an ammeter to measure current, to measure voltage, to measure or to take measurements from a human body, to take measurements concerning the electrical activity of the heart, the electrical activity of the brain, the electrical activity of the muscles, and many other measurements. Microcontrollers are used also in industrial control devices, especially for control of robots. So robotics is based on microcontrollers. We can control the robot using a microcontroller. Since a robot has multiple motors, different kinds of motors, these motors could be controlled using a microcontroller chip. So in this lecture we discussed, we provided a general introduction about the microcontrollers with some applications. In a future lecture, we will start presenting how to program a microcontroller, how to write a program in assembly language, for example, to control or to program a microcontroller. Thanks for listening.